Welcome back to Low Stress Math with Mrs. Bono. We are in Chapter 2, Graphing Lines, Lesson 2, Slope. All right, let's learn a little bit about slope. So, what does slope do? Well, it describes the steepness of a line. Now, steepness is basically the angle of a line. Now, if a line is going straight across, that's not steep. If it goes up a little bit, you could still walk. That's okay. But if it's really, really steep, then it starts to get difficult. And then if it's straight up and down, it's almost impossible. So that's what we're talking about when we say steepness. Now, you read the slope of a line from left to right. So if you're going up, it's positive slope. And if you're going down, it's a negative slope. We will get back to that. So slope is a ratio of the vertical change compared to the horizontal change. We call it rise over run. Rise is going up, run is going left or right. So it's also known as the constant of proportionality. You might remember that from 7th grade. Constant of proportionality. Now that's a lot to say, and I think slope is a little bit easier, so let's just stick with slope. The change in y over the change in x is the ratio of how much something rises vertically and how much it runs horizontally. Now, I'm going to make this really big because I want you to see it clearly. It looks like a little triangle next to a y and a little triangle next to x. That's not a triangle. That's the Greek letter delta. So let's just write a little tiny bit about delta. Now, you might have heard of delta before. We've done some delta math. You might have flown on a delta airplane. Delta means difference. So this triangle isn't a triangle at all. It's a delta. And delta means difference. Because delta is kind of like a D, and difference begins with a D. So delta is difference. Now, the difference between the vertical points on a line and the difference between the horizontal points on the line. So it's how much it's changing, how much difference there is. Now, why would they call something delta math? Well, because it's a different way to show you math. Why would it be Delta Airlines? Because there's a different kind of airline. That's why delta. All right, so let's talk more about positive slopes. So I'm going to call on my buddy here, Lefty. Hey, Lefty. Lefty always starts on the left side of a graph, and if he has to go up the graph, if he's climbing, that is a positive graph. Now, if Lefty is here, always on the left, remember, and he's going down, that's a negative graph. Now, here's my buddy Lefty, and he is liking this line. He just has to walk straight across. No up, no down, no nothing. There is zero slope. And that's a horizontal line going up and down. Now, here's a line. Oh dear, what's going to happen to Lefty? Well, here he is. He is having a problem. He's just going to fall straight down because this is an impossible, undefined slope. So those are the 4 types of slope we're going to be talking about. Positive, where you have to go up. Negative, where you're walking down. 0, oh, so easy to be 0. And then, oh God, undefined, falling down. Let us try it. Pause the video and match. What type of slope is this? What type of slope is that? You match the type of slope with the appropriate graph. Put the letter under the type of slope on the appropriate graph. Good luck. I hope you paused the video and did this yourself. You only learn math by doing math. This first one, well, that is straight up and down. That is letter C, which is the undefined slope. And this one's the straight across zero slope, which is letter D. This one, if my buddy Lefty was here, he'd be going down because that is a negative slope. If my little buddy Lefty was here, he'd be climbing up because that is B, the positive slope. Now I want to talk a little bit about points on lines. So I'm going to make this as big as I can, my undefined and my zero slopes. So what's a point on a line? Well, every single place on the line is a point, honestly. I mean, here's a point, here's a point, here's a point, here's a point, here's a point. All of the places on the line are points. But some are better points than others. Now, if we're going to try and figure out the slope of a line, we need what are called good points. And good points are at where the grid crosses and makes a T shape. So you see here in the background is the grid. And wherever it crosses, like that's a good corner. That's a corner. So I'm looking on the line to find a good corner. And let's see. Here we go. -5, -4. Right there. That's a good corner. It's where the line crosses the grid at a corner. That's a good point. -5, +3. Right there. Right where it crosses at a corner. Now, to find slope, you need rise over run. Now, you did this last year, rise over run. Okay. By rise, I mean start at the bottom point and count up. 1, 2, 3, 4, 5, 6, 7 boxes till I get to my point. Over. Oh, it doesn't go right or left. It's 0. It doesn't go over. Now, if you put that in a calculator, I grab my handy dandy calculator and I put 7 over 0, look what happens. Ooh, divide by 0 error. That's because it's undefined. You can't have 0 on the bottom of a fraction. So that means it's undefined. 0 on the bottom. And that's what makes it undefined. 0 on the bottom is what makes that undefined. Now let's look at the 0. I'm going to find 2 good points on here. Let's do -6, +5, and 2, +5. Those are 2 nice points that cross at corners. And again, I need rise over run. I'll put it down here, give myself some space. Now this doesn't rise, so it's 0 on top. And it runs 1, 2, 3, 4, 5, 6, 7, 8 boxes. Now if I put 0 over 8 in my calculator, so let's clear this off completely and do 0 over 8. And I press enter. Oh, look, it comes out 0 because this is a 0 slope. So 0 on top, that's a 0 slope. That's how you get that 0 slope. So I have the 0 on the top in the numerator, and that gives me a 0 slope. 0 on the bottom in the denominator is an undefined slope. All right, let's shrink this back down to, well, normal. And I'm not going to do these for now. We'll get back to those later. I just really wanted to go over what was a good point and what it means to be undefined and what it means to be a 0 slope. Okay, a little bit more now. So the higher the slope or the larger the slope, the steeper the line. So the larger the slope, the steeper the line. So let's just say we have a point here, and I rise 2 and I run 1. So that would be 2 over 1, that's 2. So the slope of this is 2. This one has a point here at 1 over 1, and that's 1. Now you can see this is much steeper than this one because 2 is larger than 1. Now this one, rise 1 over 2, that's a half. 1 is bigger than a half. So that's the smallest slope, but you can see it's also the least steep. Wow, that was hard for me. Ugh. So the larger the slope, the steeper the line. Now let's take a look at this. This one seems to be going up 1, left 5. So that's negative 1/5. And then this one is, let's see, up 1, 2, up 1. This is negative 1/2 because it's going up 1, left 2, up 1, left 2. This one is negative 1. And this one is up 2, left 1, 2, 2, left 2, up 2, left 1. So that is negative 2. Now, the more negative it is, the steeper the slope. This would be pretty easy to walk. A little harder, a lot harder, and oh my goodness, very difficult. So, the more negative the slope, the steeper the slope. All right, so the more negative the slope, the steeper the line. So let's take a look down here. This, by the way, those were positive slopes, and you can see these are negative slopes because they're going down. All right, think. Ugh, I know you hate that part. Which hill would be easier to walk up or down? If I started here and I'm walking up to this X or up to that X and then back down and then up and down and up to down, which one would be the steepest? Well, I think going up 3 over 1, that would be steep. But this is the same amount of steepness, down 3, 1 to the. So let's do some slopes here. All right, to get from 2, 1. Let's see, 4 minus 2 is 2. 2 minus 2 over 1. So I rise 2, I run 1. That gives me a slope of 2. Now this is obviously negative. So it's going to be negative 1 over 1. Rise 1, 2, 3 over 1. 3 over 1 is just 3. This is negative again. Rise 1 left, negative 1. And this is rise 1, 2, 3, rise, left 1. That's negative 3 over 1, or just negative 3. So negative 3 and positive 3 have the same amount of steepness, and the others are all less steep. So how do you find the slope? Well, first, number 1, determine, is this a positive or negative slope? And remember, positive is going up, negative is going down. Positive up, negative down, negative down, negative down. Now, next, count the boxes, rise over run. Now count the boxes, not the lines, the boxes. And it's rise over run. And then the last thing you do is reduce it to lowest terms. So this was rise 2, right 1. So that's 2 over 1. 2 over 1 reduces to 2. Rise 1, left 1. 2 over negative 1 reduces to negative 1. Rise 3, right 1. 3 over 1 reduces to 3. That's where those numbers are coming from. So it didn't matter, though, about the steepness, because we're going to talk a little bit about absolute value. Now, the absolute value of 3 is 3, and that's equal to the absolute value of negative 3, which is also 3. Those are the same amount of steepness. So they are the same amount of steepness. Only one's going up and one's coming down. All right, so whether you're going up or going down, it's the same amount of steepness. So the absolute value of 3 is equal to the absolute value of negative 3. All right, have a good day, and I will talk to you soon.